Students, today's topic is pressure. So before start with the pressure, we should be clear about this term thrust. What do you mean by the thrust? Thrust is basically a kind of force which is acting at a particular direction. Like if a force is acting on a surface perpendicular to the direct surface of the body, then that force is known as the thrust. How? For example, consider an example of this book lying on a table. So we have many directions to apply force on this book. Let's start from this one. If we will apply force this at this direction, at this angle, at this angle, right, this angle. So we have many angles to apply force on this book. So the angle of 90 degree, that is this one. Normal, we can say, or perpendicular to the surface of the book. So if we will apply a force perpendicular to the surface, then that force will become equal to the thrust. That is specially named as thrust. So it can be this way. If you will apply force on this side of the book, then we have to apply this way, then it will become the 90 degree. So it is also a kind of thrust. If you will apply on this side, then it should be again the 90 degree. It will become a thrust. If you will apply on this side, it will also become a thrust, because all these in all these cases the angle is going to be 90 degree. So the force is going to be equal to thrust. It is nothing else but a force which is acting at a particular angle of 90 degree. Rest all of the other things will be same as that of the force. So thrust is a kind of force acting normally to the surface, right? Now what is the SI unit? As this is a force also, so SI unit of thrust is the same as that of the force, that is Newton, and other gravitational units, kilogram force in SI and gram force in CGS. This we have done in the previous chapter as well. So we are clear about the force of thrust. Now what are the effects of force? It depends upon area of the surface, how much area we are taking to apply the force on that. And it is depending how? It is depending inversely. It means if more is the area, less will be the effect. If less is the area, more will be the effect. For this, let us consider few examples here. For example, if we will stand on a loose sand, our feet sink deep into the sand. But when we lie on the sand, like when we lie on the sand, our body does not sink much into the sand. In both the cases, this and the standing position, the thrust exerted by the body, that is equal to the weight of the body, is same in both the cases. But in one case, body is going deep. In other case, the body is just over the sand. Why? Because of the area of the body. So in this, the area is more, so effect is less. But in this case, area is less, so effect is more. Let us consider another example of nail. As we know that nail is having one point sharp and other is the flattened one. So if we will insert the pointed side into this sheet, it will go deeper. But if we will turn this and apply the same force on the body, on the nail, then it will not go deep inside this. Why? Because of the area. We are applying the same force in both the cases. In this case, as the point is sharp edge, the point area of the point is very less as comparative to the flat surface. So this has more area, so it will not go, because the effect of the force is less in this case. But in this case, the effect of force, the same force we are applying on a small area, so the effect will be more in the pointed side. That's why I told you that effect of thrust is inversely proportional to the area. Inversely proportional means whatever change you are making in this, the reverse change will happen to the effect. If you are increasing it, it will decrease. If you are decreasing this, it will increase. So by these examples, we come to know that effect of thrust is expressed in terms of a quantity that is known as pressure. Now we will come to the main topic, that is pressure. So pressure, we can define it now equal to thrust per unit area. Thrust is a kind of force acting in a particular direction. So we can write force per unit area also, but this force will act perpendicular to the surface always. So what will be the SI unit? Now we are aware about the formula for the pressure, so we can derive the SI unit for pressure. Now it is force per unit area, and we know the SI unit of force, that is Newton. Area is measured in meter square, so it is equal to Newton per meter square, and this quantity Newton per meter square is known as Pascal, as this is derived by the scientist named Pascal. So it is named as Pascal. So 1 Pascal can be written as 1 Newton per meter square. The symbol for the Pascal is capital P, small a. Other bigger units will be kilopascal. Kilo means 1000. So if you want to convert kilopascal into Pascal, wherever kilometer, just like kilometer we were doing, kilometer is equals to 1000 meters. Same here, kilopascal is equals to 1000 pascal, because kilo means 1000, right? But atmospheric pressure will not be measured in pascal. It is going to be measured in some other unit known as the atmosphere, represented as atm. So 1 atmospheric pressure is becoming equal to 76 centimeter of mercury column, which becomes equal to 1.013 into 10 to the power 5 pascals. You need to learn this value, right? Now the factors affecting the pressure. We have two factors, because we know the formula. We are having two quantities in the formula, that is force per unit area. So two quantities are there, force and area. So on these factors, pressure is going to depend. How the pressure is going to depend on these factors? As force is coming in the numerator, so it depends directly. As area is coming into the denominator, so it will depend inversely there. So pressure depends directly on the force. If you will increase the value of the force, the pressure is going to be increased. Pressure depends inversely on the area. So if you will increase the area, pressure will be less. If you will decrease the area, pressure will be more. For example, as I told you, example of the nail. Now I'm going to apply same force on both the sides of the nail. So the pressure will be more on the pointed edge because the area is less. So if area is less, pressure will be more. Now this side, it will not go deeper into this form. Why? Because force is same, but this time the area is more. Flattened surface has more area as comparative to the pointed edge. So if area is more, pressure will be less. Another example is of knife. As we know that knife is having one side sharp and other side is blunt. So if we are going to cut a lemon from the blunt side, this side, it is not going to cut this, right? But if we are going to cut the lemon from the sharp edge, then it will easily cut this. If we will cut from this knife sharp edge, the lemon is going to be cut into two pieces like this way. What will happen in these two cases? This blunt side is having more area as comparative to the sharp edge. So on application of the same force, as area is less on the sharp side, so pressure will be more on lemon. But in case of the blunt side, area is more, so pressure will be less. It will not create too much pressure to cut this lemon into two pieces. We have many more examples in this case. For example, school bags have broad straps. You can see this. School bags have broad straps. Why is it so? So that the area of contact increases and thus the pressure decreases on our shoulders. That's why they are made broad. If we will make these straps very thin, like of this much, then what will happen? In this way we are decreasing the area, and hence the pressure on our shoulder is going to be increased. So now we come to know that by increasing the area, we can decrease the pressure, right? By increasing the area, we can decrease the pressure, and by decreasing the area, as in case of nail, sharp knife, scissors, stapler, in all these cases we are decreasing the area, and that's why we are increasing the pressure on the other surface. We have many more examples. For example, railway track having wide wooden sleepers. Why these sleepers are there under the railway track? So that by keeping these, we are actually increasing the area And by increasing the area, we are decreasing the pressure, because pressure is inversely proportional to the area. So what will happen if these slippers will not be there? If they are not there, then because of the force exerted by the train on the rail, these tracks will go into the ground because of their small area. So in order to avoid this situation, we are keeping these wooden sleepers to increase the area and hence decrease the pressure. So this is all about the pressure and thrust. Thank you so much.